Okay, so now we're moving on to section 7 of chapter 6, and now we're going to talk about bone repair. So now we talked about how we built bone from either cartilage or a membrane, and we talked about how we remodel bone based off of hormones or the stresses placed on them. And now we're going to talk about what happens if we actually fracture or break our bone. So fractures are breaks, they're kind of used interchangeably. During youth, if we fracture or break our bone, it's most likely the result from trauma. As we get older in age, our bones can get weaker due to them thinning, not being as thick as they should be, and so fractures are more common. So there's a couple ways that we can classify fractures. So it could be either or. So we're talking about the position of the bone ends after the fracture. If they're in the position that they're supposed to be in, we say it's a non-displaced fracture. If the ends are out of alignment, then we say it's a displaced fracture. We can also talk about the completeness of the break. Did the bone break all the way through, or is it still just fractured partially but connected? So if the bone is broken all the way through, we say it's a complete fracture. If it's not broken all the way through, we say it's an incomplete fracture. Another thing we take into consideration with fracture classification is whether or not the bone has actually penetrated the skin or not. So if we can actually see bone through our skin like it's poking out, we say that it's an open or compound fracture. If it's not penetrating the skin, then we say it's a closed or simple fracture. And then we can go on, which we're about to do, and classify what the fracture, where the fracture is, what the fracture looks like, and how the break actually occurred. So there are 6 common types of fractures. I do want you to be aware of these descriptions because they are common. We have our first type is comminuted. So this is where our bone actually fragments into 3 or more pieces. So we're not dealing with a break in, say, a long bone in which we have 2 pieces, but we said we have 3 or more. We have a compression fraction. This is where our bone is actually crushed. A lot of times this happens to our vertebrae. The third type is a spiral fraction. So, say you plant your foot and you have a twisting force, something like that, we would get basically a spiral fraction that spirals up of the bone itself. We have an epiphyseal fraction, which is probably the most painful type of fraction, is where we have actually separated our epiphyses from our diaphyses along that epiphyseal plate. Um, the fifth type of fracture I want you to be aware of is a depression or a depressed fracture, and this is where we actually have our bone being pressed inward. So say, for example, this person got hit in the skull with a baseball. It would leave a depression fracture right there. Typically in the skull is where we're going to get these. Then we have a green stick fracture where the bone breaks incompletely, and they call it green stick because if you've ever dealt with like a partially alive twig in which it still has green on the inside, it's really hard for you to actually break it in half and one of the sides like sticks together. That's basically how they called it a green stick fraction. So one side of the shaft actually breaks, but the other side bends instead. Okay, the next thing I want to talk about is how do we repair fractures, or what's the treatment for a fracture. So treatment involves what we call reduction. So if we have to go in and realign the broken bone ends, if we have a closed reduction, this means that we can just manually manipulate the bones back into the correct placement. An open reduction, we can't manually manipulate it. Instead, we have to use pins or wires. When we talk about immobilization, that's basically accomplished via a cast or something else like that. So fracture repair, it involves 4 different steps. Let's talk about each one of these individually. So the first one is a hematoma formation, and a hematoma is basically a blood clot. So that's the first thing that's going to happen if we have a complete fracture like this right here. Basically, we're going to have torn blood vessels, so we get them, they hemorrhage, and they basically are eventually going to form a clot that we call an hematoma. We're going to have some swelling and some pain and some inflammation at this site. So we have our blood clot. The next step is that we're going to have what's called a fibrocartilaginous callus a couple days later, and this is where we're going to start getting new capillary growth into the blood clot itself. We're going to have some cells, so some phagocytic cells that can come in and remove any foreign debris. We have our fibroblast cells that are going to come in and secrete collagen, and the collagen fibers that they secrete are going to come in and they're going to span the entire break right there and help connect the two ends of the broken piece. Then we're going to have some fibroblasts, cartilage cells, osteogenic cells to begin the reconstruction of bone. And the first thing that's going to happen is our chondrocytes are going to create the cartilage matrix of repair, and then our osteoblasts are going to come in to form the spongy bone within the matrix. What we call this entire thing, this entire mass, is the fibrocartilaginous callus. One thing to point out again here is, again, we have to have cartilage in order to build the bone. So the first thing that has to happen is we make cartilage, and then from our cartilage, our osteoblasts can secrete the osteoid to make the spongy bone. The next step is bony callus formation. So we've laid down our cartilage. Now we need to come in and actually lay down some bone. So about a week it takes, and our osteoblasts are going to come in and they're going to start forming our trabeculae with our spongy bone. Our cartilaginous callus is now going to be converted to hard callus or a bony callus of the spongy bone. And this bony callus formation continues for about 2 months until we have complete connection between our two end bones. So basically the same steps as endochondral ossification. We have to go in, lay down some cartilage, and build bone from that in order to completely fix it. The last step is bone remodeling, because if you look up here, our bone's kind of not in the right place where we really want it to be. We still have some excess on the outside. So we go in and kind of clean it up and do some bone remodeling. So this remodeling can continue for several months, or even, a year or two later after you fracture a bone, you could even still feel some of the area from where it was broken. So all that excess material that we saw up here on our diaphyses, we go in and we're going to remove that, and within the medullary cavity as well. So all of that excess stuff. Our compact bone is laid down to help reconstruct the shaft walls, because we originally, if you look up here, we had spongy bone, but the external surface of all of our bone is compact bone. So we have to go in and do that. And then finally, we get something that resembles something like the original structure before the fracture happened to begin with. And then this is just a process showing you all together.